me try that again here. Okay. So I'm just going to list a few points here with just some X and Y coordinates. And I'll just pop between Google Earth. And so I'm just going to pick up some of these points here. I'm not going to share the Google Earth screen, but I'm just going to pull in. So here's like 36.8 and 108.2. 36.8. So that was like TP1 from the surveying class. Let's look at some other ones. TP2. Could actually get more. I just copy and paste these numbers here, actually. It's just probably easier than me trying to remember them. And I'll just do 2 more here just for grins. Okay, 1 more. So in Google, yeah, it doesn't matter where I get these. It could be a GPS unit for that matter, right? So I could get these latitudes, longitudes off of, just some other instrument. GPS is a common one. Let me see if I took any spaces out of that. No, looked like it was copying spaces too. Okay, so I have some numbers here that I just pulled off of Google Earth. These are just TP1, TP2, TP3. Okay, so I'm gonna pull these into Google Earth now. And I think this is how you do it. And I want to make sure I get the right. So if you go to File and Import, you can do text and CSV files. You can do all this. You can pull in all kinds of files from it. Instead of having to type them in, individually, you would just do that in a spreadsheet or something. But it'll take a CSV file. I was wondering if it would take an actual Excel file. Another good one is the GPX file, which is a native GPS. I'm sure it's in here. Maybe not. That may be under a different tool. That's weird. Yeah, I would have expected it to link. Anyhow, I'm going to look for it. I'm going to create a CSV file out of this Excel sheet here. So there I go. I have this, and save as this PC. Change that to a CSV file. Name it just GE test 1, and it's just going to my documents. I'm going to put in my drafting 248. I don't have a 248. I'll just put it in here and save it. Okay, let's close it. And I'm going to share my Google Earth screen now. So I have so just in saving that, let me turn off all these turning points here. So, okay, zoom out a little. Okay, so I'm going to import this CSV file in my documents. Oh, I put it in the drafting folder. There it is. Okay, now it'll come through some wizard that'll let you figure out, let you tell Google Earth how to figure it out. And so it's a delimited file, comma delimited. I kind of already recognize that, and pretty much it sees it as is. So I'm going to go next. And the data set does not contain latitude. It does. So my latitude field is going to be Y. My longitude is going to be X. And I'm leaving this unchecked. You can also use street addresses, which is very cool. Instead of just latitudes and longitudes, you could have addresses, and it'll read the addresses. It's not great at that, but let's just go with this since we do have latitude and longitudes. And we're good with all the type of data that you're pulling in, and floating point is just decimals. String is text, so that's it. Finish. And then do you want to apply a style template? Usually you say yes. And this way you can set the field name to name. And that'll be its labeling. And then you can pick the color. You can select a color from the field, but our color, could be just a nice yellow or something. And the icon, you can use all the same. Let's use push pin. And we can clamp the features to the ground, and okay, because I didn't put any elevation in there. Otherwise, we could set a height from a field and have like a Z field in there, which is also cool. But anyway, there we go. And it's going to save it as a Google Earth template. That's fine. And then I think this one was the 36.108. So you can see that 36 and 36.8 are several miles apart. And here are the rest of them. So there's TP1, which I just kind of rounded. And then there's these other ones that come in right where they should be. Pretty cool. Okay, how was that answer? Is that kind of what you were thinking?
Yeah, but that was like much longer than what I was doing.
Oh, so
Yeah.
So what you were doing was a lot quicker?
Yeah, all I was doing was first the longitude and latitude. It was in degree form or decimal form,
Uh-huh.
and so I used this website to convert it to decimal to minutes and seconds. And then from there, I went to tools, and then I went into the search or find,
Uh-huh.
and then it came out with the search for an address and longitude and latitude. And so when I went to the longitude and latitude, all I had to do was like put in space in between.
Yeah.
Instead of using the degrees, minutes, and seconds.
Right.
For that, and it took me to the point, and then I use that as an endpoint. And then from where that company was, I use that as a start, and I got the direction from that. And so it gave me the directions, and I use that to copy and paste that into AutoCAD, and just did all the little quick minor adjustments for the directions on that.
Oh, cool.
Yeah, so I don't think the Google Earth has that. It might somewhere, but I haven't really looked into Google Earth yet.
Yeah, to get the directions.
Yeah.
You can, like, once you get the points in there, which is pretty easy because, if you had a bunch of points, a spreadsheet works pretty well. But anyway, you can click on a point and get directions to here or from there. And you could do something like that.
Oh, okay.
So that's something else you can do. But yeah, so you might be able to use Google Earth to do what you want if you can't use that software anymore, or if it gets, if you can't get it anymore or something. But yeah.
All right, cool.
Yeah.
Thank you.
Yeah. Cool. All right. Sort of related to what we're doing. So I'll take those out. Okay. Our next We are dealing with angles, right? Degrees, minutes, and seconds and stuff still in this chapter. So there is a file that I wanted to get. Let's see if I can get there. Yeah. So this book has a website. I'll just share you that screen, I guess. And I what I want to do is, this book has a library of files, and one of the files I want to use to kind of look, just browse the properties of azimuth and bearing and the differences between them. So let's see. I'm gonna have to just do a search. There we go. Instructor's manual. Just wanted to get the could be just the student resources. Let's try that. I don't think it's in the instructor's manual. It might be. I still think it should be under the student resources. There it is. Wow, I had to go through. Okay, here we go. I'm going to go ahead and download. I'll put these in on Canvas or whatever, but this for this file. So let's just download that. Oh, okay, I was in the wrong. What are we in? Chapter 6? 7? Yeah, 7. Okay, so problem 7-9. Was that the one I wanted? Yeah, that was it. So I'll take this guy here, copy it. Oh, I can't copy it. Okay, I had to tell Windows to do that. Okay. So I'm going to open up Autocad and put that file, but I'm also going to go to Canvas and I'm going to upload this file. So you guys can get it from Canvas in just a sec. Okay. Maybe I'll make an assignment out of chapter 7 here so we can just put this link in that chapter 7. Yeah, how about chapter 7 example? I don't think we're going to do that yet. Oh, actually, we might. Here, I'm just going to put a link to here. And if I can remember what it is, problem 7-9. There it is. Okay, so there's your link to that DWG file. Let me save this. Okay, so now there is in the assignments page a chapter 7 example. And in that example, there's a link to the DWG file. And you can just, I think you can just right click on it and save link as, if you're in Chrome, and then it'll save it as an Autocad file. Okay, so I have it open already, so we're just going to go to share. Okay, it might have some, I had to kind of jump through a few hoops there. There were some linked files or, so I just went ahead and show everything. It should work. Okay, so the assignment is navigate to the textbook and download the problem. So that was the first part of problem 7-9. Determine the azimuth and bearing of each line. Well, so an easy way to do that is just with your, well, there's a couple easy ways, but anyway, with the measure tool, I can just measure this angle in here, but I don't have very good precision on that angle. And so I'm not going to get very good degrees, minutes, and seconds and stuff off of it. So let's type in units. And we can use degrees, minutes, and seconds and go to like whole seconds, I guess. and okay. And then when I measure that, there's 47 degrees, 35 minutes, 0 seconds. So that is, well, the azimuth, right? Because it's that A is the easiest one because it just measures the angle off of north there. So let's let's go ahead and do a couple of these. So 4735, that'd be this one. Guess I'm on the table layer, so that's good. And so what would be the bearing for this, for line A?
My Autocad stuck.
Oh, okay.
It says, let's get started. And I think I have to turn my computer off and start it over.
Graphics?
Yeah. I don't think there are any, but so it kind of doesn't matter. I'm going to move this table over here if I can. So it's easier to see. Okay, so the first thing to do is change your units to something better like degrees, minutes, and seconds, and set the precision to like whole seconds. That'll help. So when I use my measure tool, I can just put the cursor in between the, well, in that angle and measure that angle. So I'm getting 47 degrees, 35 minutes, right? So that's.
Okay, you said on the units, you wanted it on what type?
Degrees, minutes, and seconds.
Oh, the angle type?
Yeah.
So the length just stay at decimal?
Oh, the length. Yeah, we're not going to measure length. Yeah, we'll leave length as decimal. Yes.
Okay. So that's all we change is just the angle type.
And the precision.
Oh, and the precision. And what
Yeah,
was the precision?
Go all the way to degrees, minutes, and seconds, which is the third one down.
Okay.
Okay. Good. So when you use the measure tool, the quick tool, right? Or you could just go to angle, I guess, maybe that. But then, yeah, that actually works. We should do that. And then if we click on that and that, gives you the wrong angle, right? So that's not so great. You could use your just your dimension tool and measure those angles. But just for, well, I don't know just for what, but I'm just going to add these up because that's a good exercise too. So I got the azimuth for A as 47 degrees, 35 minutes. And then I'm going to put the cursor in between A and B, and I'm reading 18 degrees, 45 minutes. So I want to add that up for that. So I'll do the minutes first, right? Hate to do it by hand, but I'm going to go ahead and do that, or without writing anything down. So what's 45 plus 35?
80.
Yeah, so that's 80. And so 60 of that makes a whole degree, right? So I'm going to add 1 degree. It's kind of like carrying, right? So if I add these things up, yeah, I don't have a great way. Oh, well, I don't want to have to do that. Anyhow, yeah, so 80 minutes is 1 degree, 20 minutes, right? So actually it's going to be some answer in 20 minutes. Now I can go to degrees and 47 plus 18 plus the 1. So that's what, 65? So 66 degrees, 20 minutes. Pretty good. See how I did that? So that's the angle, that's the azimuth. Remember what azimuth was? It was just the angle from north. So the total angle here from whatever to whatever. Okay, so we can keep adding this up. I'm going to do 1 more for C and just measure. Well, I can't really do that because that's kind of in the way. But maybe I could just do angle here and click on that, and it didn't like it. Oh, I could do specify vertex. Haha. Let's see if I can do that. There. Do that and that. There we go. So now I can do the whole angle here to C at looks like 134 even. So that was fun. Yeah, I don't know that that's any. Let's try the let's go to the annotate ribbon and just measure angle and just click on a line and go to D. Yeah, see, that makes it a whole lot easier actually. So except my precision on my angles I got to change. So modify units, degrees, minutes, and seconds, and just do the same thing basically. So now when I measure an angle, it'll give me all the information I need, which is still just 165. Then I could actually leave it there. That's weird. Why is it doing that? Okay, well, we can make some of this work. Maybe. That was weird. Okay, so now I've just measured all the angles I need. However, so D was easy, 165. E, not so easy because it's measuring it the other way, and that's not a proper azimuth, right? So if I typed in 152, 44, 14, that's actually, it would be a mirror image. That would be in the southeast quadrant, right? And I would get an incorrect bearing on that. And it's an incorrect azimuth for that matter. So that'd be an east or a west azimuth or something. I don't even think you'd do that. So I'm going to write these 2 numbers down. Well, all these really, because I just have to subtract them from 360, right? To get the other side from north around the other way, right? So So really that's just, they should add up to 360. This one's pretty easy. H, I'll just do the ones I know. Yeah, H is what do you get for H?
60.
Yeah, okay. And then the rest of them I'll have to do some math, I guess. E, F, G, did I get E? Yeah, 152, 44, 14. Okay. All right. 44, 14. Okay. And 360, I'm gonna have to, well, oops, I don't want that one. Okay, so I'm gonna have to subtract these two numbers here, right? All right, what do I get? Well, to rewrite this, I'm going to borrow a degree. This is how I mathematically would do this. Okay, so I'm going to take 360 and make it 359, and I would write down 60 minutes, right? But I also want it in seconds, so I'm going to immediately borrow 60 seconds or a full minute out of that, right? And so that's 60 seconds over here. So there's my borrowing. Is that all right? So truly, 359 degrees, 59 minutes, and 60 seconds is 360 degrees. Because 60 seconds is a whole minute, and 59 plus a whole minute is 60 whole minutes, and 60 whole minutes is a whole degree. So 59 degrees plus another degree is 60 degrees, so 360. This way, now I can, what? Type this in. So what's 60 minus 14? 46?
46.
Yeah. Okay. And then 59 minus 14?
Or 44.
Yeah. I was already thinking teens there. Okay. Okay. And 359 minus 152, right?
207.
Looks good. Okay, close enough.
So what we'd be doing that for E or F as well?
Yeah. So right. So I'm gonna take this number and put it in my table there, 207, 15, 46. Is that right? Yep, looks good. Just mentally checking it. Okay. Can we do that with 134, 44, 4?
Yes.
Okay, so yeah. Guess I can just do this. There. Okay, what's 60 minus 4?
56.
56, yeah. And then that's no different, right? And then 359 minus 140, 134. So that's a 5 there. 5 minus 3 is 2. 3 minus 2, 1. There. That'll work.
Yep.
Okay. So 225, 15, 56. All right. I didn't measure G because, well,
90 degrees.
didn't really need to. So what do you get for an azimuth on G then?
90 degrees.
It's 90 from the north going west. So what is that going from, clockwise?
270.
Thank you. Very good, right? Okay, in H, that was 60, so 360 minus 60, easy enough. And then I, well, this one's, it doesn't involve seconds, so I know 15. I'm gonna get 15 minutes out of this thing, right? And then what? 359 minus 28. So 1 and 31, 331.
Yeah.
Okay. And 15 minutes. Whew. Is everybody all right with all that?
Yes.
Okay. Well, now we gotta, now we can just kind of focus on this part. We want to get bearings out of all this, right? So just from looking at the azimuth, I can tell, well, the first thing I would do is that one's, if it's between 0 and 90, it's in the northeast quadrant, right? And then between 90 and just going clockwise, what quadrant is 134 in? Which would be C, right? Yeah.
Southeast.
Yeah, it's southeast, right? I didn't measure that. I wonder why. Just to be. Okay, just wanted to make sure I got those right. So we added that up and it came out right anyway. So yeah, so this one's southeast, right? And southeast and southwest and southwest and west and northwest, right? Okay, pretty much this is just going to be, there's no change in the angle, right? It's all well, at least in the northeast quadrant, the angle doesn't change between the azimuth and the bearing angle, right? So these two are pretty. Is everybody okay with that? Having said that, yeah, there we go. Maybe putting a space in there is a little easier to read. Okay, what about this southeast quadrant though? That's not going to be the right angle because, well, the angle in a bearing is just how far it is off of the north line or the south line. So when I have an angle of 134 in azimuth, it's really, I want to look at the angle between, line C and the south line now because it's in the southeast quadrant. So I need the other angle here, right? Then these two, the 134 and the bearing angle here in the middle should add up to, well, 180, right? So this angle right here should be what? 36? No, 46? Yeah. Does that make sense? Oh. Is that okay to say?
Yep.
And of course, we could measure it, but doing the math is just so much more fun. Yeah. Okay, this one should be easy. I shouldn't have to measure this one. 165, what do you get? So what should be the bearing here? Thought I heard it. You said 15, right?
Yeah.
Okay. Good. Yep. Exactly. All right. What about this one? We could do this. Well, okay. Without measuring it. I mean, you go ahead and you can if you want, but I just want to point out that this angle in here is the angle again off the south. It's just west of south, right? So that's how I say it. Basically, that's south 15 degrees and east 15 degrees east, right? So that's 15 degrees east of south. Oops. Okay, so this angle is so many degrees west of south. So how many degrees is that? I almost think that's easier because it just keeps counting, right? It goes from 180 to 270, 207, I mean. So it's whatever the difference is. I subtract the 180 this time. And so I'm still going to get the 15 minutes and 46 seconds here. I just don't know what the degrees are yet. Right? So that angle is, if that angle is 207 degrees at E, so that's 180 plus what is 207, basically. So 27.
Mhm.
So 27, 15, 46, that's just the icing on the cake kind of stuff. I don't even have to, there's no borrowing or carrying here because it's just 180 plus. Does that make sense? Likewise. $225, that's 45 degrees more than 180. And then the 1556. I could say that's north 90 degrees west or south 90 degrees west or just west. Typically, just leave it as west. Okay, 300. Well, I already got the angle, right? So that's north 60 degrees west. And then this one, I already have the angle because we already like we did it the other way anyway. So what was that, 28.45? There we go. Okay, we okay? We should take a quick break. And we'll do problem 710. Well, actually, I don't think we'll need to. Well, let me look. We might do a different one instead. Yeah. Okay, cool. All right, ready to get back to it? Okay. Let's I think on number 710, we've already drawn this stuff, but yeah, we've already drawn this, but what I'm going to do instead is do it a slightly different way. So we're going to use Autocad to draw this, and you can do this. It's sort of like what we did in Google Earth, where we can just import the points and it'll draw the line, right? Well, we didn't quite do that with Google Earth, but we can certainly do that in Autocad. And I want to show you how. So just going to start a new drawing. I'm not using, yeah, I think I'm just using a regular template, but that's okay. What if I can start? I'll just import a few of the textile and stuff. So anyway, before we can start drawing in AutoCAD, I mean, well, we could just start drawing and draw the lengths and the distances and stuff. But the problem actually asks a little bit more than that. It needs the bearing of each property line. It needs the distance of each course. It needs the cosine of each bearing angle, the sine of each bearing angle, the latitude, and the departure of each course. And I'm going to add one more, and that's the northing and easting. And I'll explain that. And so it just basically wants you to fill out this table on the next page. Yeah. So I'm, of course, use Excel to do that. So let's go to Excel here. So I'm just going to use the spreadsheet. You can use whatever spreadsheet you want. I'll zoom in on this a bit. And we're going to put the course. Well, okay, now bearing. I'm going to break it up. Just to be a little bit, instead of bearing, I'm going to put my north-south line. Let's call it NS, degrees, minutes, seconds, east-west. I'll put decimal degrees. I'll probably have to make that decimal degrees, and then we can figure out what this cosine sine stuff is, but we'll explain that in a minute. And then latitude, which you think it means something and it doesn't. So it sounds like well, it's related, but not exactly what the angle latitude is. This is different. Okay, and departure. So we have course 1 to 2. Bless you.
Thank you.
Okay. Yeah. And then 2 to 3, 3 to 4, 4 to 5, and 5 to 6. Notice I'm putting a little single quote in front of that so it doesn't make a date out of it. Otherwise, it'll say like January 2nd or something like that, right? So if I just put 1-2, yeah, 2nd of January. It tries to automatically format the type of data it is. All right, so there's 1 to 2 all the way to 5 to 6. My bearing encompasses this whole, all this right here.
Are you gonna share? Are you gonna share?
Oh, I guess. Just kidding. I
No?
forgot to. Okay, sorry. Okay, so I just filled out the top. But I added, instead of bearing, I highlighted in yellow there. Instead of bearing, it's going to be 5 different columns, north, south. So I have to put a north or a south in that column, the degrees, the minutes, and the seconds, and then an east, or E or W in that other column. So that's what I'm going to fill out first, and then we'll get to this other stuff, the decimal degrees. We'll calculate the cosine, sine. We'll figure out what that means in the latitude and departure. And then I'm going to do northing and easting. So I'm just going to put N and E in there for northing and easting. But we'll get to that. We'll get to it. Okay, well, I'm just typing in these numbers. They're already right here. So 1 to 2, that's south 50 degrees east, right? I'll use capitals here, 50, and then E. And then, oh, and distance. I didn't put a distance column in here. I'm going to put that right after all this stuff. So length or distance would go there. I'll leave it yellow because that's actually what we're typing. The rest of it gets calculated. So that's nice. South 70 east, north 30 east. Four to 5. North 55 west. We'll type in these distances. We'll give you time to, catch up if you need to. Everybody okay up to here?
How do you stop your box from this? It says January subject or something like that. How do you turn that off?
I just put a single quote in front of the 1-2.
Oh,
In fact, I put a single quote in front of all of those. So I just typed in single quote 1-2 instead of 1-2 itself. And that forces it to not automatically format the values. Well, the first step then would be the decimal degrees. Now, there's no calculating here because there's no minutes and seconds, but I'm going to go ahead and just go through the formality of it anyway, right? So it's going to be, because, you know, we may be able to use this later, which I think we will. So it's going to be the degrees plus the minutes divided by 60 plus the seconds divided by 3,600. Does everybody know where that comes from or remember where that comes from? And I went to like 6 decimal places on this because when you get to like 36 hundredths of a degree, you know, with seconds, that can go, you know, if I put a 1 here, you know, that gives me, you know, those last 3 digits kind of important. So there you go. That's why you have to put more significant digits on your angle measurements if you can. Okay, so I'm going to fill that down. And there's the decimal degrees. So that's nice. Okay, the distance. Now, as far as the sine and cosine goes, you know, what's up with that, right? Well, I'm going to take, basically it's just going to equal the cosine, right, of the decimal degrees. So cosine, decimal degrees. This isn't sufficient though, because again, most spreadsheets only use radians, so I got to convert it from radians, to radians, by multiplying it by pi and dividing it by 180. Hit the wrong button, there we go, 180. So I'm taking 50 degrees, multiply it by pi, divide it by 180, and take the cosine of it, whatever that is, right? Fill that down. So you get a bunch of numbers. You know, what does that even mean, right? We'll get to that. We'll just go ahead and do it. Do the sine of the same thing, right?
So on that sine, did you do the G2 times pi divided by 180
Yep.
as well? Okay.
You have to, right? Yeah. Okay. Well, before I get to latitude and departure, that's the whole reason for doing sine and cosine. In fact, you could just leave these out and just incorporate them into the latitude and departure. But it's nice to separate them so you see what's going on. Okay, so here's what's going on. Let me share the sketchboard again. Okay. So here's the deal. Draw some straight lines. Here's north, south line. Here's east-west line. So if I have an angle here, let's just put it in the northeast quadrant. We'll do one in each one. So here's a line that has, actually, let's draw a more important line. Okay, so we have a direction coming off at some angle, right? Okay, so I'll just define what latitude and departure is first. That'd probably be most useful. I wonder if I can. Can I make a dashed line? You know, just make a purple line, I guess. 'Cause purple's cool. Okay. Can you hear my dog drinking water? She's
Yeah.
so loud. Okay, so if I make this right triangle here, there's two possible right triangles that I get, right? One side of the triangle, in fact, I guess I don't really need this one. I mean, that could be over here, just to make one triangle out of this thing. And the triangle I want to make is against the north-south line. And that goes for every quadrant. So it doesn't matter what quadrant I'm in, I'm going to make the right triangle with the north-south line. It's always going to be 90 degrees at the north-south line, no matter what quadrant I'm in. In fact, let's just draw a couple. So I wanted that one to be black. Okay, anyway, here we go. Okay, so this line right here, I'd be tempted to draw it off the east-west line, but I'm not going to. Right, that's the triangle I'm after. So no matter what, you get a right triangle off the north-south line. Okay. Here's the deal. The direction or the distance you go in the east-west. So if I break this up into how far I go north-south and east-west, the east-westness of it is called the departure. Okay, and the north-southness is called the latitude. Can't rotate that. Oh yeah, no, I can't. Anyway. Just leave it like that, I guess. Okay, so the north-south distance is latitude, the east-west distance is departure. Now this is useful, especially when you're using like GPS coordinates and things like that. You just get an X and a Y basically, right? GPS will give you latitude and longitude, by the way, but that's not the same latitude. I mean, it sort of is. I mean, it is how far north and south you, well, it's not. But it's similar. So if it helps you remember that latitude measures your distance in the north or south direction, then that's great. If not, then it's no good. It's no good otherwise. So here's the angle, right? This is your bearing angle every time, right? That's the bearing angle from the south, right? In the southwest quadrant, that's the angle I'm concerned with, right? So if I want to get the departure, right? So there's a departure here. The purple line is my departure, and the north-south line is what I'm looking at as far as latitude goes. If if I want to know the departure, what trig function is going to help me, right? Because I know the distance here, right? This is my distance. Okay, so that's the hypotenuse of this triangle. So the departure is in relation to the angle. What is it? As far as the trig functions, remember some old hag came hopping through our alley, or Sokotoa? Remember that? Did we go over that? Yeah, we went over that.
There will probably be opposite.
Yeah, so the departure is the opposite side, and likewise, the latitude is the adjacent side, right? So if I want to know what the departure is, what trig function am I going to use? If I only know distance and the angle, which is what you are given,
Maybe cosine.
well, I want opposite, right? So that's going to be the sine is the opposite over the adjacent, the hypotenuse, right? So that's the old hag part, right? So old hag, and so my distance times the sine is going to equal the departure. Algebraically speaking, the what, O over H, basically your opposite, your departure. Okay, let me rewrite that then. I'll abbreviate that. My departure over my distance, or the length of the survey. So when you're out there in the field with the total station or something, you measure the distance and the angle, right? And so you get you're going to measure your bearing angle, most likely, or your azimuth, and be able to convert it to your bearing. And so now I have the departure and the distance. And that's going to equal, right? The ratio of that triangle is now I said cosine, yeah. The sine of the angle. We'll call it alpha, but that's your bearing angle. Whatever the bearing angle is, I take the sine of it, and that's equal to the departure over the hypotenuse, or the distance, right? So I multiply both sides by distance, or the hypotenuse, and so I get the departure is always equal to the distance times the sine of that bearing angle. Likewise, without having to go into a ton of detail on that, like rehashing it all out, what's the latitude going to equal then? I'm going slower. Right? I'm going to use alpha as my angle, but yeah. Okay, that's it. So that's why we figure, that's why in the spreadsheet, you're always looking at latitude and departure. Okay. So let's go over to AutoCAD. I think it's this one. Or not AutoCAD. Yeah, no wonder. No wonder it's blank. Excel spreadsheet. Okay, so I got the cosine and the sine, and so the latitude is equal to, well, it's just the distance times the cosine, right? I'm doing it backwards this time, but there it is. And the departure, what if I do this? What if I just hit F4 on that and lock it, right? And then just drag that over. That's why it's in that order. Latitude, departure, that's the northing part, and that's why cosine's first, because cosine deals with the latitude, sine deals with the departure. So see what I did? Distance times the sine, that's equal to the departure. And distance times cosine is latitude. I can highlight them both and double click them. And there it goes. Now I know the latitude and departure of each course. Basically from point to point, it's called a course. And latitude and departure tells me the distance in each direction. So that's nice.
Can I see the function for departure again? One more time.
What is it? Somebody help her.
No, what happened?
Right? Do you see why departure is sine and latitude is cosine? That's kind of key.
Okay, I just lost my distance now. Can I
Say
see
what?
the distance formula again? I just lost my distance formula.
There's no formula for distance. It's just what the book has for the distance,
Huh.
right? I just typed those numbers in. Those are just right from the book. Is that what you were asking or something else?
Yeah, when I changed it to 262, but then all of the other numbers changed as well.
Good. Well, supposed to, right? What was it before you typed in 262?
It was 262, but then all of the other ones turned to 262 as well.
Say that again. I didn't catch you.
It was 262, but then when I went to click on it, it turned to, I put it back in as 262, but then all of the other ones down below it changed to 262 as well.
Oh, were they highlighted or something? Can you change them to be what these are? Can you change the numbers now? Back to what they
Yeah.
should be?
Yeah.
Not sure why
Okay.
that would have happened. That's weird.
Yeah, it just kind of like freaked me out.
Is it working now though?
So yeah.
Oh, okay.
So then I do H2 and then I F4 it to lock it and then multiply it by, for departure, I do for
Times the sine,
cosine?
yeah.
Okay.
And the only reason to lock the distance. Okay, I see what you're saying. So I did it wrong. I'm only supposed to lock not the 2, right? So let me take out the $sign in front of the 2 because that'll lock the row also. And that's not what I want. So let's fill that down now. And I should get some different numbers, right? So that's H.
Yeah.
Forgot to take that one out. Yeah, there we go. So these filled up there. Right? Distance, course, the course distance times the cosine is the latitude. Course distance times the sine is your departure. We okay with all of that? Okay.
My numbers are different than yours, so.
I might be wrong still.
Because I did $sign x2 times I2, which is the cosine
Yeah.
line.
Okay, but make sure there's no $sign in front of the 2, right? Just in
Yeah.
front of the H on everything, right?
Yeah, so for the departure, it was actually for the sine, right? Not the cosine.
Right.
But yeah, okay, that's where it went. Okay, get so many. All right, now I got the numbers.
Okay, cool. Everybody else all right? Garrett? Noah?
I got it.
Okay. Um, okay. I'm going to highlight this latitude and departure. And add another sheet. Let's see if this works. not super sure how it's going to work, but I'm just going to paste it here. Wait, did that not work? Highlight that, Control C. Oh yeah, maybe adding a sheet didn't quite, and then Control V. There we go. Oh, hold on. Okay, here we go. Control C, and then right click, paste just the values, not the formulas, right? Just the values. Actually, let me try something else. I think I can do this in Notepad. Paste. Yeah. And then backspace, I don't want the, well, yeah, I do want that end in there. See, what I'm trying to do is replicate like a polyline command, right? So if I type in, if I can remember, let's see, PL, and then enter. I'll just use enter to make it easy. And then it asks for your start point, and maybe I'll just type in 0, 0. Oops, 0, 0. And then it'll ask for the next point. And if I do, actually, I want to reverse this, don't I? Let me back up. So this would be a great start, 0, 0 for my first point, and then return. And then I type in the distances, the latitudes and departures. So it'll start the polyline there, and then it'll just draw the rest of it, right? Okay. However, oh, dang it, I'm stuck. Okay, so here is where I want to switch these columns, right? This is actually the X direction, and AutoCAD wants X first. So I'm just going to switch these around. Just move them over. Okay. So here are my departures, and here are my latitudes. So the Y coordinates are second. And then I'm going to highlight these. I'm going to copy, Control C. Okay. And then I'll jump over to, maybe I'll just share my screen here. How about that? There. And then I'll jump over to my notebook. And so I type in PL, enter, to go to the next line, 0, 0 for the first point, and then enter. And then I paste my numbers. Okay. And then for whatever reason, Notepad sees these tabs as the delimiters, right? Instead of a comma, it puts these, but that's okay because I'm going to do a Control H, which is what I call a search and destroy, but that's a find and replace, right? So if you go to edit and replace, Control H, right? I can find, what do I want to find? I want to find a tab. So I don't know how to make a tab in here, but what I can do is highlight that tab and Control C, and then just paste it in here. So there it is. There's the tab. And you can't really see it, but I'm going to replace it with a comma. And replace all. There. Now I've made a comma separated values sheet.
Cool.
Okay. This will be fun. So if I can remember, if I can just mentally go through the exercise of drawing a line, basically, but I'm going to do a polyline. How about just a line? I don't need a polyline. Although sometimes I'd like a polyline. But a line would do the same thing. So L space or enter, right? In this case, it'll be enter. So everyone's on a new line. Just makes it easier to read and instead of spaces. I could just do spaces, but that'd be tough. Okay, so L, enter, 0, 0, enter. And then if I type in this number, comma, that number, and then enter, it'll go 200 in the X and 168 in the Y, and then go to the next point. And they'll do it again and again and again. And then enter, right? Oops, don't have too many enters or else they'll start another polyline. So there it is. If I just have one more, so my flashing cursor, I need to have right at an end of a blank line here. And then I'm going to, actually, I don't even need to save this. I'm just going to copy it. Right, so Control C. Okay, that's all the command I need. So let's go to, oh, wait, let's go back to my screen. Let's go to AutoCAD. Where's AutoCAD? There it is. And then just type in here in the command and paste. I have to click in my command line or else the paste will just paste all that text. So click in there and Control V, and then I think it might have done it. I guess I needed one extra line, so I'll just hit enter. Okay. That was really cool. Didn't quite work though, did it? This line looks like it might have worked. Let me see what went wrong. So 262 in length, that's great. Oh, I know what went wrong. Okay. Let me figure this out. Let's go back to Excel. Does anybody know what went wrong? Back here? Well, it's sort of a tricky question, but basically, if I'm going south, I should have a negative latitude, and if I'm going west, I need a negative departure. So I forgot about that. Right now, it thinks I'm going all north and east, but I'm not, right? Some of the stuff's south and some of it's west. Okay. So there's a couple things you can do. Maybe the easiest one, well, I'm just going to go over one and then we'll go over a different way. And I think it's easier. It's even easier than this way, but this way is pretty easy. So here, right in cosine, this cosine has to do with latitude, right? So I'm going to check for the north-south. And if it's south, I want to make it negative, right? So that means I'm going to put an if statement in here. And if what? If that is equal to an n, then it'll be just this. I'm going to copy this. If not, then it's negative that. Put it in parentheses. See what's going on here? Basically, it's going to be positive if it's north, and this is what happens if it's not north. That means it's south, so it's just negative cosine it. Is that okay? So that's the deal. So I'm going to fill that down. And yeah, that'll work. Similarly, I'm going to add that to, well, of course, I'm going to add it to my sine also, right? So I'm going to check for east-westness. And if it's east, I'm going to do that. And if it's west, I'm going to do negative that. See if this works. And you can see immediately, right? My wests give a negative sine, and my souths should give a negative cosine. And therefore, my latitudes and departures should be negative and positive accordingly. And that looks like it is. Okay, so now I need to recopy this and redo it. So I'm going to copy this, come back to this other, actually, yeah, I do need to copy it in the sheet, just the values. This way it makes it easier to,
How do you copy
again,
the values?
switch them around. Say what?
How do you copy just the values I got? The red numbers, how we run from mine.
Yeah. Do a right click. See here, let me go back to the sheet. Okay, so I copy, Control C, right? Then I come over to the other sheet and right click and copy just the values. So you get all these, you get these paste options.
Yeah.
Just use the values. Okay. So now these are my X and Y coordinates. So I'm just going to copy these and go to Notepad now. So Control C again. And where's my Notepad? Right here. So I'm going to just paste these guys in there and do a Control H. It's already there. So, okay, now I have two lines in here. So if I copy them, hopefully, or just Control A and Control C. Now go to AutoCAD. Click once in your command line, Control V, boom. Did that work?
Oh, we're not supposed to close it?
No.
Uh,
Yeah. Did that not work? 89. That line's only 89. I don't think that doesn't look right. It's almost right. This line looks a little off. That should be 250. No, that line. This line, yeah, that's 200 and down 168, so that's good. $200 and 237 and down 86. Oh. Um, it looks like it's using absolute coordinates. I was expecting it to use relative coordinates. So let's try it. Let's just do this. We put this at 0, 0. And then it doesn't matter where this is. And I'm going to just type in these numbers that I see here. So I'm just going to go 200, negative 168. So, comma 168, negative 168. And then 237, comma negative 86. See, that's what it should have done. Why didn't it do that? It was super close. And the rest of them did it. What's wrong with my... Oh. That ended the line command. Is that right?
Really? Yeah.
So that would be line, and then 0, comma 0, enter. And then it would go to the next point, 200, comma that, and then enter. And then that asks for, that ends the line command. That's why. Well, no, it doesn't. It shouldn't. And then I should be able to just type in. So that should have worked. Try it again. Where is it? Okay. It still only does that one. Here we can do F2 and look at the command. So line, specify first point 0, 0, next point that, next point 237, negative 86. It didn't do that. Why didn't it do that? Oh, there's a, no. Wow, it's so close. I just want to make it work. So that line starts at the end and it just ends at that absolute coordinate for some reason, rather than just going from the end to the end. And the rest of them work, which doesn't make sense. Those are just the coordinates. Oh, that did it too. Okay. So maybe not. Oh, I think it's just AutoCAD. If I set the dynamic input to, oh yeah, no, that's dynamic UCS. My dynamic input, where is it? See if this works. Still didn't. Okay. For whatever reason, it's inputting the absolute coordinates. So that's actually pretty good, because that's what our northing and easting is, right? So if I want 0, 0 to be my starting coordinate, let's say, or any number, okay, then my next northing is just going to be this, okay? It's going to be my original northing, my first point. So if I want to go from point 1 to point 2, I'm going to take the coordinate of point 1 and add point 2, or the latitude, basically going north and east. So we're doing north first, and we'll switch them to get to AutoCAD. So I'm going to add that. If it's negative, it'll go down. So we're always adding, and then we'll just do it again, right? Till we get to here. So basically, the only point I don't have is 0.6, which means I just need to go down one more. And that'll get me, that's the coordinate of 0.6. So here's the coordinate of point 1, 2, 3, 4, 5, and 6. Otherwise, it's just course 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. And that's how far I would go, but I can't get the coordinate unless I add one to that. So that's good. That's good. Similarly, I'm going to add the eastings and the departure, right? So my starting at 0, add the departure, and then fill that down till I get to there. So these numbers, I'm going to kind of zip through this because we ran out of time. Anyhow, I'll paste values again. And we'll finish this on Wednesday or whatever, but just want to show you. Good notepad now. See if this works. Okay, this with two spaces on it. Okay, Control A, Control C. Get me to AutoCAD now. Here we go. Paste. There. So those are just absolute coordinates. I thought AutoCAD was defaulting to relative coordinates where you just typed in, I mean, if you type in a number, if I just draw here and I go 500, 200, that went over 500 and not 200. So I don't know why when you paste that in there, it doesn't. So anyway. Got it to work. There's our drawing without having to draw it. Okay, well, we'll see you guys Wednesday, I guess.